Our video today is going to be on area of certain objects, in our case, quadrilaterals. So area in general is the amount that something covers something. So think of painting a wall. How much paint do you need to actually paint the wall that you're dealing with? That's what we deal with in area. So there are specific formulas that we're going to be working with in this area. In general, the basic idea of area is you can break up an object into what we call square units. So if we look at this object here, that's a long rectangle. Each of these units is a 1 square. So if we add them up, the area of this object would be 9. We could change the shape of this and it'd still be 9. Again, we can change the shape again and it would still again be 9. So it's the amount that we can cover in a certain area that we give the numbers to. So here are the special formulas for special quadrilaterals that we have to work with in this year. So if we start with a square, we know that all sides of a square are equal. So our simple formula for this is going to be simply A equals S squared. So in this part, we're going to be using powers to use this because it's the same number times itself. For a rectangle, it is simply length times width because our sides are not the same, but two of the sides are the same with the rectangle. So it's simply length times width. So you only need two numbers in this case to deal with it. For a triangle, we have our base, which what it sits on, and our height. And sometimes, most of the time, the height in a triangle is given by a dashed line. So you got to be careful with that in order to find the height of that. It's going to be with a dashed line for the most part. So it's half a rectangle. So we say that it's base times our height divided by 2. Now you could also write it this way. You could say base times your height divided by 2. And if you can simplify one of these two numbers with that 2, do that and it makes your problem a little bit easier. For a parallelogram, again, we're looking at base times height. In this case, you're really looking for that height to be given as a dashed line and it goes down to a right angle. That will take you to your base. So your height is your dashed line. Your base is what it basically is. It's what you're sitting on. So this one just is, again, it's similar to a rectangle, but we say it's base times height. The one that's the most complicated, I think, is the trapezoid. I'm going to relabel this a little bit because that's how I'm going to work it with ours, even though I'm going to use the same formula at that juncture when we get into problems. So instead of this A up here, I'm going to change this and I'm going to say it's another B. So you have two bases. So what they generally say is base 1 plus base 2, and then we'll put the 1/2 in front of it. And then we deal with the height, which again, look for a dashed line. So our real formula that we're really going to work with is 1/2 times our height, base 1 plus base 2, and then we're going to just multiply it all the way through. So again, look to see if you can reduce the 1/2 with the height if it's an even number. So with the work expectations of each of these individual problems, this is what I'm expecting to see from you in your work shown area. Sorry about that. And that is, you're going to start with the formula. So depending on what it is, you're going to put the formula down first. You're going to put the numbers in for what is given. You can just do that right underneath, and I'll show you the examples of what I'm looking for as I show you the work that I'm going to show you. Work down the paper. Don't work across, left to right. Work down the paper from the formula. And be very neat with this. You want to make sure that you have everything that you need in that problem to show all the steps that you're going to use. So some of these problems are pretty basic in what you're doing. So if you notice, I have now started with using my formula as we work through this. I've already got it written. So I look for the length and the width. So the length is 5 meters times 3 meters, and we're going to try and get away from that using that x, and we're going to use parentheses. So we have 15, and we have 2 meters. So the way that we show that is we're going to show it as meters squared. So in the next problem, we have a rectangle that has 14 by 28 units or yards. So again, we're going to start with the formula and work through it, and we're going to put in 14 yards, 28 yards, and when we solve this and multiply them together, they come up with 392 yards squared. Squares are the easiest. We've got our two sides. They are only going to probably give you one at some point, but just know that all sides are equal. So we're going to put our 9 yards in, and we're going to square it, which is really like saying 9 yards times 9 yards, which gives us 81 yards squared for our answer. So with triangles, yes, you're going to get decimals. Probably not going to see fractions, but yes, you're going to get decimals as you go through this. So just be careful as you go. But again, set your formula up, which I did. So I'm going to put in 1/2, 2.6 centimeters, 7.3 centimeters. Once I go through and multiply all this, I'm going to go in and I'm going to get an answer of 9.49 centimeters squared. For my bottom one that I've got, same thing, but now I can look at seeing if I can reduce something. So if I have 1/2 times my 2 centimeters times my 6 centimeters, if I notice that my 2's would reduce to 1 each, 1 times anything is itself, I still have my 2 centimeters that I'm working with, so it's 6 centimeters squared. So it makes it a little bit easier sometimes when you deal with that. So for parallelograms, one of the things that they're going to do is they're going to go and give you more numbers than you need. Remember, you only need the base and the height. So this slant line here, we don't care about that. It doesn't mean anything. The only two numbers that we need is this one. So again, there's your dashed line that gives you the height. It goes to, in this case up here, a right angle, but these two sides are the same. So when I throw this in, I'm going to have, again, my base is 58 inches. I'm going to multiply that by 44 inches. And when I multiply those two numbers, yeah, I got a big number, but it's okay. 2,552 inches squared. So again, you're going to have decimals in here, so again, you're going to have to work with it. So our base in this case is 2.1 centimeters. Sorry about that. And I have 5.9 centimeters. So again, I'm going to have centimeters squared. And when I come out and multiply it, it's going to be 12.39 centimeters squared. So with our trapezoids, again, I'm going to rewrite this so it's a little bit different. So it's 1/2 height, base 1 plus base 2. Just telling you that there's two bases there. So again, we're looking for our dashed line for our height. So our height is 9 kilometers. Our two bases are 11.5 kilometers plus 21.5 kilometers. So again, I would take care of all this first, which would give me 33 times my 9, and again, these are kilometers, and my 1/2. So I would multiply probably those two first, and then divide it by 2, and I'm going to come up with 148.5 kilometers squared. So if you notice in all this, area is always units squared, and these are your units right here. So this last problem is one of the tougher ones, or the longest ones that you're going to have to deal with, because you have two trapezoids put together. I refer to this as kind of like the barn because it looks like a barn. So the barn problem. What happens is you have a sharing of a height, or excuse me, a base in this case, and that's going to be right here. So the easiest thing to do for yourself is literally redraw this, put in your numbers, come back over here and draw the other side. So you're going to have two problems that you're going to need to deal with. But again, if you take everything in stride and say, okay, 1/2 height, base 1 plus base 2, 1/2 times our height, base 1 plus base 2, you shouldn't have too much of an issue with this problem. So if we throw this together, we're going to have in our problem 1/2. Our height in this case is going to be 18. And we're dealing with this as the first object, this as the second object. And that makes it a little bit easier once you identify what you're dealing with. And then you have the two bases that you're sharing. So 5 plus 22. And if we set up the other one, we have 1/2 times our base, which is going to be 12. And that's going to be 22 plus 13 for our bases. So again, if you notice, I can reduce here to simplify. I can reduce here to simplify. So I really have 9 now times 27, and I have 6 times 35, which will give me two different areas. So then this one I have 243, and then this one I have 210. The last thing I'm going to do is I'm going to add the two together, and that's going to give me a total of 453. Now in the original problem they didn't give us any units like centimeters, kilometers, yards, feet, inches, whatever. So we would label this as units squared, or we can just say U squared. So if you follow the steps, you put your formula first, you show your work going down the paper like I did in the video, you should have no problem with this section at all.